Griffiths' Introduction to Quantum Mechanics, Problem 1.4. At time t equals 0, a particle is represented by the wave function psi of x0 equals capital A x over A. If x is between 0 and A, capital A b minus x over b minus A. If x is between A and B, equals 0 otherwise, where capital A, and B are constants. Question A. Normalize psi. That is, find capital A in terms of A and B. Integral of probability density rho x dx equals 1, and the probability density rho x equals squared absolute magnitude of psi. So 1 equals integral from 0 to b squared absolute magnitude of psi dx, which is squared absolute magnitude of capital A times integral from 0 to A x over A dx, and integral from A to B minus x over B minus A dx. Which is squared absolute magnitude of capital A B over 3. So squared absolute magnitude of capital A equals 3 over B. So capital A equals square root of 3 over b times e to I5. Capital A is a complex number, but we can choose phi equals 0. So A equals square root of 3 over b. Question B. Sketch psi of x0 as a function of x. Psi of x0 equals square root of 3 over b x over a if x between 0 and a. Psi equals square root of 3 over b minus x over b minus a if x is between a and b. This part is a straight line, and when x equals 0, psi equals 0 as well. And this part is also a straight line. When x equals b, psi equals 0. If a is here and b is here, psi may look like this. Question C. Where is the particle most likely to be found at t equals 0? The probability rho of x equals Square the absolute magnitude of psi. So rho may look like this. Obviously, when x equals a, rho is max. The particle is most likely to be found at x equals a. Question D. What is the probability of finding the particle to the left of A? Check the result in limiting cases, B equals A and B equals 2A. To calculate the probability of finding the particle to the left of A, we are going to calculate the integral from 0 to a rho of x dx, which is integral from 0 to a squared absolute magnitude of psi dx. And the result is a over b. If b equals a, the wave function would look like this. So the probability is 1, which equals a over b. And if b equals 2a, the wave function would look like this. It's an isosceles triangle, so the probability is 1/2, which is a over b.